So this question starts off by providing us with a system of equations. Anytime I see a system of equations, I'm thinking of two methods. One is elimination, and the other is substitution. So just writing that out just to remind you that these are really the two methods that we're going to typically use whenever we have a system of equations. And I usually only use substitution if I see that there's a variable isolated, which technically, honestly, in this case, there is, right? So that means I can take these two equations, combine them into a single equation by replacing this y with what the first equation says y actually is. I'm going to just do that. So this becomes 2x squared minus 21x plus 64 is equal to 3x plus a. Okay. Then I can simplify this, of course, by subtracting 3x and subtracting a from both sides. And what I'm left with is, and I'll go down here for space, 2x squared minus 24x plus 64 minus a is equal to 0. The question itself says, in the given system of equations, a is a constant. The graphs of the equations in the given system intersect at exactly 1 point. Okay, so graphs are mentioned, which means I could graph this by hand, but why would I do that if I have a graphing calculator? So most likely we're going to use a graphing calculator here. So they intersect at exactly 1 point, xy, in the xy plane. What is the value of x? All right, well, in order for me to figure out the value of x, I'm going to first of all need to figure out the value of a. How can I figure out the value of a? What do I know about this new equation that I have? Well, I know that there should be a single point of intersection. I know that this equation is a combination of two equations that could be graphed. I could have just, if this wasn't an a here for my second equation, I could have just graphed it. But I can't graph it because of the a that's there. So whenever I know that I'm going to have exactly 1 point of intersection, I can use another thing here called a discriminant. And this is used quite frequently on the digital SAT. So I would definitely get used to it if I were you. The hint, again, is exactly 1 point, exactly one solution. Those are the wording that I see on the test. The discriminant is b squared minus 4ac. And what you should know is that if b squared minus 4ac equals 0, that represents having one solution. So for us, 2 is our a value, negative 24 is our b value, and 64 minus a is our c value. So I'm going to just plug all that stuff in. So b squared will be negative 24 squared minus 4 times 2 for a times 64 minus a for c. And of course, that has to equal 0. Negative 24 squared is 576 in my calculator. This becomes all of this becomes minus 8. Then I distribute that 8. 8 times 64 is 512. So minus 512. And then 8 times negative a is minus 8a. It's actually positive 8a because it's a negative 8 times negative a equals 0. 576 minus 512 is 64. So 64 plus 8a equals 0. I can then subtract 64 from both sides. And I have 8a equals negative 64. And therefore, a equals negative 8. So that's the value of a. So now I have exactly what I need to use in my graphing calculator. So I'm going to just clear this up a bit. So again, if I now know that a is negative 8, I can take both of these equations, graph them in the integrated Desmos calculator or onto my own graphing calculator, and I'm just looking for where do they intersect, right? So when I do that, I will find, let me just go to my calculator that I have here. So I find in my graphing calculator that the point of intersection for these two is at x equals 6. So therefore, the correct answer here should be choice C.